Hey, the project today is about controlling an AC light with the infrared remote control. And here is our Arduino Uno board that will do much of the work because it has a microcontroller responsible for the reading of the inputs and controlling the outputs. But it is only possible because of the codes created in the Arduino IDE and uploaded here in the board itself. So it has digital headers from 0 to 13, which it could read binary signals such as switches, relays, and could output a voltage to switch on the output components. And we also have these analog ins here from A0 to A5, where we will connect our analog components such as potentiometer, rotary encoder, and among others the light detecting resistor. These headers here is for the power, and we can see the VIN, the ground. So if you want to go mobile and you don't like to use this jack, you could put up to 20 volts here. And then we also have this ground again and the 5 volts or the 3.3 volts where we could source a power for our output components. So guys, for this project, let's deal the input side first. So we have this infrared receiver module here. It will detect an IR or an infrared transmitted by this remote control, which is actually a transmitter. And you can see it has a G in the first pin, an R in the second pin, and a Y in the third pin. So let's plug this little thing already in our breadboard somewhere here like that, and let's start the wiring. And by the way, I will be using this rail to make our wiring a little neater. So the J or the G pin shall be connected to the negative rail. So this yellow wire will goes here to here, while our or the middle pin, the R pin, should go to the positive rail. So this is the middle pin right here. So it must be connected or pinned in the positive rail. So while this third pin here, which is the Y pin, we will connect it in the digital header here, and I like to connect it in the pin 8. So I like to turn this board upside down. So we have this Y pin or the third pin here like that, and I would like to connect it in the pin 8 like that. And then we need a power for this module, so we will get a power from the board. So we need to jump this ground here. Next to pin 13 is a ground, so we need to jump this ground into our breadboard and the negative rail. And then we will get the 5 volts on the other side here. next to the ground is a 5 volts, so it must be here, and we will connect it to the positive rail here. So guys, I think this circuit is initially done, and if the power is on for this board and the codes are already uploaded, this circuit will be ready to receive a signal from this remote control, and we could map out each button of this transmitter. And if we knew the addresses of these buttons, it could be possible or easier for us to make a conditional statements to control our output components. So let's do the coding now. So I'd like to open our IDE. So guys, here is our IDE, and I am using the bare minimum. So don't worry about the sketch of this project, because in mapping out the buttons, there are a lot of references in the internet, and because the codes in mapping out of the remote control button is generic or is standard. So first we need to include the library of the IR remote, and this is how you will write or how you will include your library. We need a hashtag include, open it with a less than sign, then the IR remote a dot h, and close it with a greater than sign. If you still don't have this library, just Google it and search for the IR remote Arduino library, and the link will give you the chance to download or to download the library. So next we need to define the Y pin. So define, let us say let's call it the Y pin, which was connected to pin 8. And then we need to create the objects of our Y pin, or we need to create an object which is connected in the Y pin. So we have this IR receive, and it turns orange. It means it is recognized by the Arduino. So we will call our object as an IR, which is in the Y pin, and then you need a semicolon right there. Then as per library, the result shall be found, or the decoded result, we need to create a variable where we could find the results. So we have this decode underscore results, and we will call the variable signal receive, signal receive, like that. So guys, let's go down to the void setup, and actually we have nothing much to do in the void setup but to initialize the serial monitor and enable the IR module. So we will have like, let us take this out, serial that began with a 9600 baud rate. So the serial monitor is initialized, and then next our object IR that enable IRI, so it must be in capital N, then it turns orange, and then we have this thing, or we have this module, the IR receiver module got to be started. So let's go to our void loop, and in the void loop, if the button is pressed, and our signal receiver is ready to receive a signal, we could have like an if statement that goes like this. Let's take this out again, this one. So if, what's your, if the IR, our object that decoded, or IR that decode, which is found in the signal RCV and the parameter R and signal RCV, which is equals to 1, then we need to see the result in the serial monitor. So let us print the value in the serial monitor. So it must go like this: serial dot print ln signal RCV that value in a hex form. So actually you can do it in decimal or in a binary, but it's quite difficult, or in a binaries the numbers are too long. So and uh, and a base 16 is practical. So then we need a delay, which is 1500, and that delay is enough to not to get a wrong signal. And then after, we need to reset the module for its next reading. So it must be like IR that resume, like that. So guys, if we upload this sketch, and we could see how it works. So plug our let us plug our circuit here. Let us plug our Arduino in our computer. So before we will upload this, like that. And so let us plug this thing, and let us try to upload the circuit now, or let us try to upload the sketch now. So guys, we'll be expecting that if one of the button here is pressed, we could see the hex address of the switch in the system, or in we could see it in the serial monitor. Problem uploading the board, CTP support. Why? What happened? Let us upload this again. Alright, you hear that little noise there, so I think we're good now. Let us upload the sketch again. Okay, done uploading. So let us open our serial monitor. So guys, let us press any buttons here. So I'd like to press it with 0, like that. So you see the receiver is blinks, and the serial monitor we get FF6897. Let's try another button like that. So the 100 plus button is FF9867, the the number one button. So we have FF30CF. So what this means, that each button here is unique. The address of each button here is different to each other. So now we could start mapping this thing out, and I like to make an array of these buttons. So let us try to do this like this. So we have this. Because the hex number is like too large to hold in the integer, we need to have a data type, the unsigned long. So we have this unsigned long, and this square bracket, which is equals to like that. And let us say again, what is this 0 button? So the button 0 is 6897. So I think we have to do like that. This one here. So it must be in our first array is 0 x 68, if 6897, if 6897, and then oh, where did I go? Zero x ff 6897, like that. That is the first item in our array, and that is a 0. And we will try this one, this first or number one button. So we have this if 30CF. So again, we have this 0x if 30CF. And let's just try 3 buttons first. So this number 2 button, we have this if 18E7. So 0x if 18E7. So every time we press the button 0, I need this 0 will be displayed in the serial monitor. So let's have another data type here, and let's call it a button press, and it should be in a char like that. Button press, which is equals to like that. And then, so therefore we will have a conditional statement right here. If the signal received, that value, C, control V right here, is equals to what is our array? Let us name this one button right there. If the signal received, that value is equal to button in the first array like that, which is 0, okay, right there, our curl is good. Our button press should be equals to 0 like that, and then serial.println because we need to see this in the serial monitor. Button press. So I guess we could expect that if the button 0 is pressed, we could see the hex value, and next is the number 0. So let us upload this sketch again and let us see how it works. Begin 9600. We have I lost this curlis here. Okay, upload this again. So I think it's getting good. So let us try and let us open our serial monitor and let us press 0. Alright, so we have this hex value of FF6897 and then the 0 again. We have that one, And if we press 2 or 1, nothing comes 1 because we need to change that 1 right there. So 2. Okay, I think it works. So let us try this with our array, the second array, which is 1. That is the second array. Remember how to do arrays. So this is 0 1 2, so this is 1. So if we press 1, we could have this like 1 here, and let us upload the circuit again. Okay, let us open the serial monitor and let us try. I'd like to make a brand new serial monitor. Let us try this one. So if we press 0, then we shall have only FF6897, and if we press 1, that we have this one. But I want this at least have a little delay, so I need somewhere this one. We need to transfer this one. Control C, somewhere here. Control V, and let us delete this, and we have to upload again. Okay, let us press 0, and our serial monitor will be just like that. So guys, please ignore the function decode and result is deprecated, because after all it works, and deprecated means it is recognized. So let us press again 0, then we need to press 1. That now I get the wrong signal right there. So 1 right there. So if 30CF 1, if 30CF is 1. So guys, now we could create an if statement, but first we need to wire our output components, and we have our output components, a relay. So let's move this thing now. So a brief introduction for this relay. So the relay has two sides. This side here is for the high voltage, where we will connect our AC light. So the middle terminal here is the common, so which is coming from the source, from the AC source. Let us say our source is 220 volts. So one line is here and going to this line here or this line here, depending on your choice or depending on your project. And in this project, I want to connect this common and to the normally open contact, because once this relay is receiving a signal, I want this normally open contact to get close so that our AC light will turn on. And this is the low side voltage. You can see here the S right here, the S, the plus and the minus, and the S pen will be connected to digital headers, and the positive and the negative will be connected to the source. So let's plug this relay right there, and so our is I like to connect our S to 10, pin 10 right here, and the positive will be going to the positive rail, right here, and the negative rail and the negative pin, so right there. So guys, I think we need to go back to our sketch and let us have our new declaration of variables and the new setups with having new entries in our void loop. So let's have this one here. So we have now a relate pin. Let us say define relay pin, which is equals to or 3, I mean 10, and then we will have this, because this project is we need to switch on and off and this relay in a single button, so we must have a relay state initially equals to off. So I like to make this end relay state is equals to 0, and to make this happen we also have a bool data type, which is will be taking a track the false and true of the button. So we have this ball press. Let us see, we will use the button 1 underscore 1, which is equals to false. So guys, let us proceed to our setup. We have a pin mode right here, which is pin mode relay pin, which is an output, and then let us go to our void loop. Let us say if the signal received that value is equals to the button array 1, button press is equals to 1. So we could have a statement here like button press, I mean this boolean press underscore 1 is equals to true, like that. And if press underscore 1 is equals to true, like that, let us get this thing here, Control C. So let's just have it here, Control V, and let us delete this one here, like that. So if press 1 equals to true, and if, because we want our relay pin to get high, if relay state is equals to 0, then another like that, then we have this digital write relay pin is high, and again this one will become 1. Control C, enter, Control V. So this must be equals to 1. Else, if we press the button again, or if the button is pressed, if else means that the release state equals to 1, so we have an else statement here, like else digital write relay pin low, and then our relay state, Control C, I undo, if I can do it, Control C, like that, here will be is equals to 0, and so this curly's here, curly's here. So what will happen to our previous one? This one will become false, so that could be read or it could be reset. So enter, Control V, this one will become false, like that. So guys, we will be expecting that if we press the button 1, this relay, the normally open relay will close, and the normally close will open. So we could recognize this if the lead indicating in the relay will be switched on. So let us upload this circuit right there. Alright, so we do not need now a serial monitor to monitor or to track the button press, but we will make sure that our relay will be switched on. So if we press 0, nothing happens to the relay. 0. And anyway, let us open the serial monitor. So 0, nothing happens. Let us press 1. Right there. You see, you heard the click of the relay. Now it's switching on red. And if we press again the 1, get the wrong signal right there. It's switched off. Now guys, it will be possible now that the AC light will be controlled. So let us wire our AC lamp. I will get our AC lamp. So this is our AC lamp here. We have this plug that will be connected to the appliance socket, and this is the wire, and this is the lamp. and the wires here, you are seeing that two wires will be connected to the common and to the normally open circuit of the or the normally open contact of the relay. So let's do the wiring now. So the source is the black one, so it must go to here. And remember, I told you that this one here is like and this is the normally open contact here. Anyway, but be careful because this side here is in AC, so it would be dangerous for, or it could be a little caution about this one with electrocution. So guys, let us plug this thing now, this one, to our appliance. This one, let us plug this thing now, and I like this plug in the ah this one. Oh, so right here it's already plugged, so we should expect that this light here will be switched on if the button 1 is pressed. So I will be doing like this, and just make sure that the target will be directly, or the receiver is visible right there. So let us press 0, nothing happens. Let us press 1 right there. Wow, it's working good. And press again. And getting, because once this one has emitting and illumination, it will disturb the infrared of this remote control. So I like to be put it like it here at the back. So let us have this one here, right there, right there. So guys, this thing works properly, and I think I must have a clear. Let us try this one in a distance. So I will go a little further. Press 1 right there, but this relay is disconnected, so like that. So again, let us switch that thing off. Okay, so I guess it's good. And again, right there. So you see, like that. And again, it would be difficult now to switch this thing off because of the light. So there is a disturbance somewhere. So but now it's going good. Again. So guys, I think it works, and I hope you learned something out of this project, and I will share you the code again for you to copy. And anyway, I intentionally make the fonts a little bigger for you to have a clear view in your cell phone. So it should go like this, and this is our sketch. Not so difficult, not so simple, but if you understand this thing, you can do a lot of multiple things about this one. And I want to recommend you to continue the mapping of each button. You can use array, or you can use like coding it one by one. So guys, thank you and have a nice day to everybody. Please, next, my video is about controlling the light with a sound sensor. Bye bye.